No, it's closed. No one will be here. Nobody will be here. Yep. And then what we're supposed to do is we're supposed to come back and talk about antiderivatives, right? So I don't think there's enough time for us to sit in groups and do more problems to practice. So can we just spend the next 8 minutes, let me pass the sign-in sheet around, and let's talk a little bit about antiderivatives, see if we can get some of this taken care of. Because I know, I know some of you already have some experience with it. So we'll get some of the basic stuff out of the way. By the way, the quiz that y'all graded the other day, there were 24 quizzes. There were 6 people who got above 70, and then the rest did not. Just so you know. My other class was very similar. I have a Tuesday, Thursday class also. All right, make sure you initial that. All right, let's talk about antiderivatives. And this is 4.7, antiderivatives. So in calculus 1, all we did was derivatives. So there should be some antiderivatives we should be relatively comfortable with. So as an example, if I ask you to find antiderivative of f of x equals x squared, then not x squared, let's go with 2x. We talked about this, I think, on the first day. Then you're just saying, hey, like, what do I take the derivative to get that, right? So we're all comfortable with the idea that it would be x squared. Yes. All right, so we could say, how do we say it? Well, what we usually do is instead of using the little f, we use capital F of x to notate the antiderivative, and then we write x squared. But then we soon realize that it could be x squared plus any number. You could have x squared plus 1, x squared minus 7, x squared plus pi. As long as there's a constant out there, it won't matter when I take the derivative of it, right? So we just put plus c, all right? So let's try something else. Find antiderivative, question, huh? Oh, of f of x equals, how about just x, not 2x? Well, it should seem natural that we should need the x squared, right? Because the power, when we take the derivative, the power comes down, right? So it's got to be x squared, but I can't use that because the 2 would come out and I don't have a 2 here. So what I need to do is just throw 1/2 in front of it, right? And that would take care of the 2 when it comes down. And then I could still again say plus c, and that would still work, right? Now, it gets very tedious to have to write down, find the antiderivative over and over and over. So instead of doing that, we have notation for that lets you know to find the antiderivative. Just like we use that little prime to mean take the derivative, that was like real quick notation. The quick notation that we have for taking antiderivatives is this symbol right here. It's like an S that's been stretched out. And we will talk about where it comes from and why we use that. But short story is that it's the Greek letter, the Greek sigma, and it's some weird kind of mutation of this gets us to here. But that'll come later, okay? We don't have time to get into that today. So in other words, if I write this with 2x right here, that's telling you to find the antiderivative of 2x. That's that right there, right? But there's one little caveat to this. We have to also put behind this dx. Now this dx is called a differential, and we will again address that later, like what it means, where it comes from. But really, you can ignore it when you're thinking about the problem. You're just saying, okay, what's the antiderivative of this? And the answer here would be x squared plus c, right? Okay, so let's do another one. What would the antiderivative of 5 be? And that's not correct to just write 5, right? I need to put this little differential dx there. That's just, what? 5x, right? Plus a constant. What's the antiderivative of pi? Pi x plus c. So I would hope that if you're trying to find the antiderivative of a constant, everybody's cool. Everyone's got that? Yes? All right, so what about this? What about the antiderivative? What about the antiderivative of x to any power? So not x squared, not just x. It could be x squared, x cubed, square root of x, doesn't matter.
1 over n minus 1.
Okay, so yeah, what we can do is just use the idea that we know what differentiation does, right? It brings the power down by 1. So I know my answer has to have x and then 1 more than this power, so n plus 1. That way when I take the derivative, I'll subtract 1 from this. It'll go down to n, right? But the n plus 1 is also going to come out when I take the derivative, right? So I need to scale this. I need to multiply this by 1 over n plus 1. And that way when it comes down, it goes away, right? And then we add c to this. And this is actually a formula. This is what we call the power rule for antiderivatives. But there's a problem. It doesn't always work. There is a value of n that I could put in there that would cause problems with that formula. What's the value? If n was negative 1, right? Because what would my formula say if n was negative 1? 1 over 0, and that's undefined, right? So let's look at that special case. What if n was negative 1? Then that's the same as 1 over x, right? And that you should recognize because you did that in Cal 1. The derivative of something was this, natural log. So we put natural log, and we normally put absolute value around the x to make sure that it's defined, and then plus c. So what we say here for the power rule is this. This is the formula to find the antiderivative of x to any power so long as n here is not negative 1. If n is negative 1, then it's just this, natural log. So this is a very nice formula, and we will pick up there next class, next Wednesday. We will just start doing antiderivatives of x to different powers. Then we'll throw some more algebra in there that'll make it more complicated, and then we move on to our first technique of integration. Or no, we'll do some, I think we're going to do some Riemann sums first. And then we'll do substitution. September 19th is our first test. Which one is that? The take-home one? Oh, yeah. Y'all can put those up here. Do you want to ask me that question? You got it? Sure? Okay. So who was right? Were the tutors wrong?
Yeah.
The tutors were wrong?